Okay, thanks a lot, Christian, for invitation and introduction. I hope you can see my screen. Basically, today is the December 6th. So in December 6, 1990, there was the foundation of Esoro. So actually, beer seems to be the topic of the evening. So today is actually Esoro's 32nd birthday party. But nevertheless, it is a pleasure for me to spend that time with you. To be honest, it was also related to beer when Christian and Andrea were convincing me to make this talk today. Esoro is, we are an engineering contractor, and so obviously often our projects are kind of secret, and we cannot talk too much about this. So that's also one reason why we are a bit not so known. But just to give you a picture, that was how it was looking electromobility in 1990. These are some pictures from the Tour de Sol with the racing car from Solar Team Hunk, which was then converted to Esoro out of the rest money of sponsors after those races. I myself, my name is Stefan Commentin. I'm not here since 32 years at Esoro, but since 22 years. So actually, I started studying mechanical engineering also because I saw races like this. Just to give you a bit some data from the past. This is the car that won 4 times in a row these Tour de Sol races. It is about 400 kilograms heavy, curb weight. Of that is 180 kilograms are batteries. That was the time of lead acid batteries, and it was found to be a good car if half of the car weight is batteries. The trick of that car was that it's a very low drag, and you see the power was about 12 kilowatt peaks. Nevertheless, you could race up to 120 kilometers an hour. Honestly, today you would not like to do this anymore. The consumption was about in mixed traffic about 35 watt hours per kilometer, which is probably a fifth of what you use today. So, and nevertheless, the car was also capable of transporting quite a lot of beverage. So that was the small introduction story. I will tell you a little bit more what we are doing. I will go through some projects as examples, and I will, since we are a battery community, give you some insights what we are doing currently in terms of batteries, and in the end there will be some time for discussions, I hope. Esoro, as said, was established in 1990. We have only one headquarter, which is close to Zurich in Fallanden at the Greifensee. It's 100% owned by management and staff. The management is myself, Stefan Commentin, and my colleague Fabian Grob, who is with the company since the beginning. We are about 15 people, mainly engineers, and as you can see, most of us are here since a very long time. What are our services? So what we are doing is, it can be told in different topics. So we are doing conception and innovations for customer. We are doing engineering, conventional engineering and products development. We can do prototyping and manufacturing of let's say, very small series or single pieces. And we do some consultancy work too. And in which areas are we working? So most of our projects have something to do with electrification and alternative drivetrains. And especially we have a lot of activities in battery systems too, which is closely related to that. Then what is probably most known of us are our work in concept cars. There if you're interested in cars and a little bit older, then you might know a lot of the Rinspeed cars. And we have some med and rehab technology projects too. Just a bit an overview concerning our know-how in electrification. We do this, as said, since 30 years. We electrified cars, trucks, ships, and construction machines. We do battery, fuel cell, and hybrid cars. And in that field, we do prototypes and serial development. You can see here just some projects we already did on nautical and road traffic. As said, most of our projects are a bit under the cover, so we are even later not allowed to tell what we are actually doing for whom. One famous project was probably the coke fuel cell truck. I will come to that later also. Concerning batteries, we don't do battery cells itself, logically, but we do, let's say, packaging of cells. We do a lot of cooling. We do a lot of connection concepts. We do casings of battery, and we do some simulations in the battery world too. This is typically something we do also for OEMs. We have some electric knowledge and have our proprietary BMS system, and we can do things finally to approval, for example, according to nautical applications. So we did many offshore applications. We also did a rail track construction machine, which you can see here. So different projects. And as I said, what you dream is what you get was a long time let's say, our main published project stream. We did a lot of vehicles for Geneva Motor Show. I will show you of these cars just as an example what is happening. That I have to say, a lot of these look more like engineering that they are. So the main purpose of those cars was to demonstrate sometimes technology, but mostly like stickers or technology of sponsors. But apart from this, we also did several concept cars for automotive car manufacturers. Then just some pictures from our more rehab technology projects. We did a lot of wheelchairs. We did a lot of the seating topic is a large topic in rehab industry, and there we have also a large customer where we have different projects. So this is just some of our customers we work for, since most of them since many years. So there are some of automotive industry. We have some newer automotive industry. We have also suppliers of the automotive industry. For Weber Automotive, for example, we did the smart tailgate door. And yeah, some of you might know. And just to bit understand what kind of relationship we have with our customers. So we are probably, for some, especially for when we work for R&D departments of OEMs, we are kind of a strategic engineering partner for pre-development, especially. Sometimes we also do like general contractor for complex projects of our customers. So, for example, electrification of a product or hybridization of a product where the customer basically has a lot already ideas what he wants to probably build in the car, but needs someone that cares about all the stuff in between the new components and the old. Then we do a lot of engineering and realizations of concept or prototypes. So there we are more an extended workbench for our customers. And some of our projects are kind of classic engineering services in design engineering. I will show some projects examples to give you a bit of an understanding how a project looks like. This is an old project. It looks like a quad, but it's actually a wheelchair. It is four-wheel driven, four-wheel steered, electric powered with a hybrid hybrid engine in the back. It is running only 15 kilometers an hour, so it's not 50 kilometers an hour, only 15, because read from approval, it's a wheelchair. The special thing about that, it's that if you're sitting in this seat, you can the seat is tilting with the if the car drives upwards, then it tilts you to the front, and if it goes downwards, it tilts you to the back. This is because if you're disabled, you don't have probably less muscle in your waist, and that helps the people to stay comfortably seated in the wheelchair. This wheelchair was actually it is not really. It was available. You could buy it, but it is a kind of a top of the line product of our customer. So the customer wanted to position himself somewhere higher than he was mentioned so far. So it started all with I think with a beer with his designer, and the designer so the legend was painting something like that on a beer on a beer carton on the table. And so this was basically then the start of a project. With this, it's not finished, obviously. So after that, we did all the 3D modeling, the entire engineering, search for components, engineering of the frame and safety and stuff like that. You can see here also there is a kind of a rack where you can put your manual wheelchair. So there is an arm here that comes to the front when you want to enter the wheelchair. So it's basically you can drive this by yourself without assistance, and it's also meant that if you're driving a normal wheelchair, you're very often stuck only if the road gets a bit steep or a bit dirty, and with this you should have more the ability to travel further. Then after realization of first prototypes, we tested that here. It's in Arosa, somewhere at the Roton in winter. We then did the entire approval for the TÜV. And since it is from a building side, it's kind of a different technology. So it was basically made from sheet metal. We produced here at our company about the first 10 samples, and we instructed the workers from our customer to be able afterwards to manufacture it at their site. So, and this is basic about what we are usually able to do. So we can do about a series of 10. So we are not a real producer, but so if 10 is a number that's feasible for us. In terms of electrification, everything is known what has four wheels, but electrification, to our experience, has a lot of other topics that you probably at the beginning don't think. So that's a quite big sailing yacht. It's 175 feet. It's a sailing boat that, and the steering, because it's that big, it's quite far away from where the captain is standing usually. So usually this is then made with large chains that going down and up to the rudder, that is limiting a bit the design of the boat, and is also in terms of comfort not state of the art, so to say. So what we did is an electric steer by wire with force feedback. So you're basically allowed to drive here with one finger the entire boat, and you can also change the kind of the gears between the steering and the rudder. So this is just another thing of electrification. To explain a bit, so in these projects there is a lot of engineering, and in the end you see only the steering wheel, and the rest technology is somewhere under the hood. And the Greenspeed projects are a bit different. So the entire thing is to realize the idea of our customer within a very limited time, is usually 6 months. It starts with some sketches of the designer, some basically concept studies. Then you need to engineer and elaborate the entire packaging, which is in 3D, but also here since limited of time, you just need to define how much engineering is really needed for that project, and when it's time to go to the workshop to do the entire realization. And here you see under the hood, it's not such, it's maybe, let's say, very pragmatic approach. We can do fiberglass parts by our own, then you set it up here. Usually the drivetrain in this for cars like this are loaned from other cars. The basics of this car was Renault Twingo, which was cutted in slices in length and width, and all the four corners were put a bit more in larger distance. Then we do the software development for let's say user interface, and that it runs also on a very pragmatic approach. And then at the end you have to make an initial operation and to test it a bit, so that you're able to ship it somewhere, wherever weather is nice at the time, and the environment fits to the idea of the car, so to say. And then you make pictures and movies. This is then maybe, as I said, 6 months after project starts. And honestly, after the movies, I would say 80% of the lifetime, kilometer lifetime of the car is already done. So it's a very, I mean, it looks like then that's the idea of it. It looks like have done a lot of engineering, have needed a lot of technology, but basically it's a realization job. And obviously, as you see, this is more a futuristic car where the idea is to autonomous driving and changing the cabin and stuff like that. That's interesting because the first cars of Rinspeed had more the sporty appearance, and meanwhile the Rinspeed is also it's more a visionary of future mobility. Like the opposite of Rinspeed in a way is if we were working for OEMs. We do a lot of DMU concepts, so digital mock-up, not only of entire cars, but also of batteries or drivetrains. So we do this in a pre-development phase because, as you know, most OEM, they do not, most of the things they give out for suppliers to manufacture later on. But to be able to specify what they give to their suppliers, they need to develop it to a certain point where they are sure that conceptually it's what they want. And that's most a phase where we are helping them. We also did or do realization of mules. And so if probably a customer or a supplier wants to demonstrate their, for example, their drivetrain, they need a vehicle to demonstrate it and to benchmark it also against a standard vehicle. And that's also something we do. So we take a benchmark car, we remove the drivetrain, we implement the drivetrain from the customer, and then they can take this in operation and benchmark their products against other competitors. And probably an interesting, we work a lot on batteries, and we have a lot of the engineers of our customers are former developers of motors, of petrol engines, of gearboxes. So it's actually for me quite interesting that it's a bit so in earlier days you say all the Chinese, they are just copying the things from European or American manufacturers, which was certainly true, and now it is a bit the opposite. So the technology comes from Asia, and our customers, which are located mostly in Europe, so to say in Germany, they need to catch up, and it's quite interesting how in the end it's a lot of mechanical engineering basics, and it's interesting how let's say conventional mechanical engineers learn electricity and learn batteries and to how they proceed in solutions. So I'm actually quite optimistic that a lot of them catch up fast and develop interesting products. So and what's the main difference between, for example, a Rinspeed and the project here? Let's say the deepness of technology and the deepness of engineering is just another dimension. So you can see here, this looks like a mess, but these are all pressure and temperature sensors that were built in a car just to learn and to be sure that it behaves as you planned and under all the circumstances that you could ever imagine that happens to a car, that you can gain the results. Okay, then another project that was famous, at least in Switzerland, was this first fuel cell truck we did for Cope and the project that generates hydrogen here in Switzerland. So we did actually the implementation of the entire fuel cell system and the hydrogen system. The truck was already electrified. The fuel cell was from Swiss Hydrogen, Swiss manufacturer. So just a bit an overview. There is the truck, obviously. There are the tanks here behind the cab. There is a fuel cell part. There is a part that cools the entire box here behind. And there is, and that's actually why I'm telling you this, there is a lot of batteries too. It needs also be charged, and the fuel cell is just only a part of that. Here in that project, we checked all at the end, all the lane guards and functions. We need to approve that it is able to start up fully loaded at 30% slope. We did all the EMC, you might know all the EC R10. We did the engineering of the rack and of the fuel cell system in terms for the approval by the TÜV. And so in the end, we got the first license plate for a fuel cell truck, which was also some time ago. And we could also prove that the truck is able with hanger to run approximately 400 kilometers in one day. So, but why do I tell this in a meeting of all battery people? I mean, there is always some kind of sometimes a bit religious discussion between fuel cell vehicles and battery vehicles. And as you might have understood, we are an engineering supplier, so we always have the opinion of our customer in a way. So I don't I don't make here an opinion on every single project, but just on a battery point of view, fuel cell vehicles are also just interesting battery vehicles because every fuel cell vehicle has a battery, and the demands for a battery is a bit different than you would expect from the first view. The power demand, since the battery is smaller, the power demand is pretty high. There are a lot of dynamics that is not capable to be done by the fuel cell. Then if you need to have a kind of a third brake in the truck, so you would like to give quite some load to the battery in terms of braking. And all this, since the battery is small, has a lot of cooling requirements for the battery, for example. And what you can see here, the blue line is the temperature. That's actually the same the same tour that we had here, and there the temperature outside is quite moderate, so to say. But what you see, the red line, is what happens to the battery if it's not properly cooled. So the battery turns to be hotter and hotter and hotter, and the limit of that battery was quite about 45 degrees or something. But then it started to really reduce the power, and that means if you don't do this correctly, you end up here, or if it's warmer, you end up here kind of in a deadlock. So the battery gets warmer and warmer and warmer and doesn't allow to get charged. So it gets emptier and emptier and emptier. And at the end, even if the fuel cell is running, you're quite facing a moment where you're not able to drive anymore. So whether you think fuel cell is a reasonable thing or not, from battery perspective, it offers quite some interesting technological aspects. Also, term of weight and space that is quite limited, since the other technology uses quite a lot of space. And obviously, costs are also always a problem. So this leads me a bit to the last topic. Would like to just give you just some more keynotes what we are doing in battery at the moment. We are facing a lot of thermal management issues. So for our customer, we have a lot of cooling conditioning issues. For example, for fast charging is quite a so to say hot topic at the moment. It also the thing with low temperature spread within each cell, or which is within the module, is in terms of lifetime very regarded as very critical by our customer, and they are for sure right. Then still there are a lot of power and energy density issues. Is it volumetric or gravimetric? And also getting more and more important topic before is the thermal runaway, and obviously the cost of entire system. And concerning this thermal runaway, I would give you just one insight of a project series we're doing at the moment. As I said, we have nautical projects, and we equip boats or especially sailing boats with batteries. It's probably not something what you would really expect on the first look, but as you see, the boat is quite large and the boat is quite costly, and there is a lot of luxury items and luxury rooms. So there is a quite large need of electricity or power, so to say, in the boat. And it is not so comfortable if there is a diesel engine running all the time when you sail to a decent spot and you have to hear all the diesel and hear and feel and smell the diesel all the time. So what those boats sometimes need is a battery. It's about 120 kilowatt hours, which is what you need for a night, for example, if you need to run your AC and all the other things that you could wish on a boat. So this is so a decent size, and we built this from normal NMC modules, usually pouch energy cells, liquid cooled, and then the batteries, they are somewhere hidden somewhere in the space. You wouldn't believe, but also in a ship on this size, it is quite difficult to find spaces. So that's also one reason why high energy density gravimetric and volumetric is very much needed. But there are different requirements, especially concerning thermal runaway. So at the moment, still in the automotive industry, it is just common, or it is accepted that the car, if there is a thermal event on a battery, is burning down, and you just need to have enough time to leave the car. But on a boat, it's quite different, because there is no trunk where you can sit on and see how the boat is burning down. So and also endurance-wise, it is quite the requirements are quite high. So there is only a limited amount of lithium cells that is allowed to burn. There is no fire allowed outside of the box, and there is no uncontrolled gas flow allowed out of the box and into car. As you saw, the batteries are usually placed somewhere inside. So the requirements are quite harder than for automotive industry. And if you want to use automotive industry packs, then it is needed that you have more measures to take. And what you see afterwards, we made a short experiment to demonstrate what I said before. We have a test setting of a box containing 3 modules. The battery, there's complete mounted bus bars, BMS, everything. The battery status is preheated to maximum operating temperature. It is fully charged, and the test trigger is a steel nail that you penetrate in the middle, 30 mils in the middle of a module. I can show you a short movie about that. I hope the bandwidth is okay enough. Seems to run. So you see then on the left-hand side is a pack that we did where there are no measures. So you can see both are penetrated same time. And on the left-hand side, even if there is an exhaust, the fire is coming out of the box, even if it's an aluminum box. And on the right-hand side is when you take the right measures, there is the box staying in a untouched, so to say. The smoke is coming out of this pipe, which is in that case even insulated, so there is no risk that the hinges or the walls where the exhaust is mounted to are overheated. It is a quite nasty experiment. You also don't want to stay here where the white smoke is coming out, but it's let's say more comfortable that if you are in the same room where this happens here, it burns out of the box, and it obviously ignites all the things that are around. But I thought, since Christmas is approaching, I show you how to ignite the fire. I wouldn't actually recommend it to do it on lithium ion, but taking normal candles for that. I can skip the rest of the movie. You see at sometimes it just gets white smoke, and on the other hand you still the burning battery. Yeah, that's basically all I have to say. Obviously, unfortunately, I'm not allowed to tell you all the detailed stuff of our current OEM projects, but hope I could give you some information about an old company that's a part of the battery community since a long time, but always a bit under the radar, since we are not doing so many activities to announce.
Yeah, so, Stefan, thank you very much for your insight. I think that was very interesting. First of all, I would say, 32 years. Congratulations from my side. I think most of us were probably little boys at that time, so super impressive this birthday, and I hope you have some beers to celebrate afterwards. And also very interesting the insights you show us with this ship and boat batteries. As this topic, I think is becoming more and more interest, as with the new ECE 100 regulation. There is also a propagation time inside, and it's rumored that this time is going to be extended in the future. I think this is an important topic, and I think the knowledge that you build up is not only for boats valuable. I think, as you mentioned before, at the moment it's somehow accepted that the car can burn, but I think for the future this won't be the case, and therefore interesting to see what you're doing. With that, I would like to thank you and open the discussion. So please raise your hands virtually, and I hope you have some questions to Stefan. At the moment, this is not the case, or nobody wants to start with the first question. So maybe I can start with the first question. You showed that you use NMC cells for ship application. Do you see that it as NMC cells become more nickel rich and therefore I would say they have a bit more aggressive way they behave? Is it more difficult to fulfill the for example DNV-GL regulation, or how does that behave?
Honestly, we just used, we didn't change the chemistry so far. We just used those that we have that are that we were supplied with. The reason why obviously it would be much easier to use LFP or something that's less aggressive, but for the applications we have, its weight and space is quite important. So the yachts are made from carbon and light wood and stuff like that. So they do a lot to keep the boat light, and obviously they fill the weight afterwards with wine and other luxury items, but nevertheless the weight is quite critical, and that's actually the reason why we use these NMC automotive cells. But I cannot say if newer generations will be more critical.
Okay, thank you. So I ask again to the audition for questions. Marcel Held, please.
Yes, thank you very much for the interesting presentation. I have a question to the battery management system you mentioned. Is this how is this limited? I mean, could I come to you and say I have a battery or a module with this type of cells, this combination of series and parallel structures that can use your battery management system, or would you adapt it to specific batteries?
Basically, we could, yeah. It is what's a bit special. It has an active part, so we could actively balance cells. This is maybe something that's a bit special, but yeah, if you have interest in a BMS, you're welcome to ask, and then we see if it fits.
So, but it's kind of a standard battery management system you have. You don't develop it for different.
No, we
projects.
developed this. We developed this by our own, so it's really proprietary.
Okay.
I need to make some light here.
And maybe a follow-up question: you have different BMS for different certifications, or you use for automotive and for the ship industry the same battery management system?
Basically we have our BMS for our projects. Usually that's why it's made for. In automotive industry, I have to say that most we don't equip serial car with our BMS, so usually then as I said, we help our customer to develop the packaging or to specify how to or to develop how to specify the battery for the project that he needs to, which needs quite a lot of engineering, but later on in automotive industry they have suppliers which supply for the project and the BMS.
Good. We have another question from Volker Nerlich. Please, Volker.
Yes, thank you for the presentation. I have a question about your battery system. So I'd like to know whether what kind of, or why did you choose the liquid cooling system? I guess it depends on the C rate. What these C rates do you expect, and how does a cooling system is going to be operated? Always during operation, or only when temperature level will be exceeded?
You think for the nautical battery?
Yes.
Yeah, but the main reason is that you need to cool it, and the battery is somewhere hidden in the boat, so it's not it's difficult to have an air cooled system, and you also want to be dry, let's say in a dry room. And the reason actually the discharge rates are not so high, but they used to use, or we found out that our customer, they used to charge in 1 hour or maybe 2 hours. So actually at the beginning, the main topic was that they want to have a silent night. So during the day, they thought to use the diesel all the time, and then at the end, it's anyway full at the night, and then they switch off the diesel and they can spend the night quietly. But they kind of came to the conclusion that they want to have the diesel run only for minimum hours. And that's why also they let it run for 1 hour, then the battery is enough full, and then they live for the next 11 hours, and then they run it again. It's actually quite interesting. So with the boats, they have quite a high consumption of diesel, and we had recently a customer that sailed from over one of the Great Lakes, I don't know, and they saved about 60% of the fuel only because they lift from the battery. So usually you need you need hydraulics and stuff, and then the diesel usually is just running, and it is running in a very unpleasant operation point, and you just use your fuel. And with these hybridization, you can run the diesel just for a limited time on a higher efficiency, and then you can live from electric during the rest of the time. That saves a lot of fuel.
Thanks.
Good. Yeah, maybe one last question to Stefan. Well, if that's not the case, I would say once again, congratulations. It was not a Santa Claus idea. It was apparently a good idea 32 years ago, celebrated tonight. And Hopsweets to everybody. And I hope to see you all next year for the Battery Tuesday, which will start in February with Anton Paar about material characterization. And therefore, I wish you good vacation, good Christmas holiday. See you then. Bye-bye.
Bye-bye.
Thanks a lot. And
Thank you very much.
bye.
Bye-bye.
Danke allerseits. Tschüss.
Tschüss.
Ciao, danke.
Tschüss.